All right, so we're able to solve it. So what we want to do is divide both sides by VB squared, and then divide both sides by MA, and then take the square root of both sides. And so the final result is this formula right here, with a rate, which is the same as velocity. Velocity is just a rate of speed. So the rate of diffusion, how fast it's diffusing around in a particular volume, is equal to gas A over gas B is equal to the inverse square root of their masses. So the mass of gas A, which is on top of our rate, goes on the bottom. The mass of gas B, which is on the bottom of our ratio, goes on the top. And so I'm going to solve a few problems using this formula, which is a statement of Graham's law. The velocity of gas A compared to gas B is equal to the inverse square root of their masses. All right, so here's our first problem. It's the velocity of oxygen molecules is 0.757 meters per second. So there's a speed, distance over time. That's the rate of velocity. What would be the velocity of H2 at the same conditions? So the velocity of O2 compared to the velocity of H2 is equal to the square root of the mass of H2 over the square root of the mass of O2. Or, in this particular problem, we could solve, just leave it this way, the mass of O2 times the velocity squared of O2 is equal to the mass of H2 times the velocity squared of H2. And just plug those numbers in. So this one's a pretty straightforward plug and chug. So we know the mass of H2 from the periodic table, 32. The velocity is 0.575. The mass of H2 is 2.02. And we're looking for the velocity of H2. So it would be 0.575 meters per second over x, if you prefer, square root mass of H2, square root mass of O2, and solve for x. So you could take the square roots and divide, or you could cross multiply, however you know how to do the algebra. Let's do 2.02. That's not how I do it on this calculator. I got to hit the second. 2.02. So there's our square root of 2.02. Square root 32. So I could say the square root of 32 times 0.575 divided by 1.42, and I get 2.29. Units would be per second. So that's the first kind of calculation involving Graham's law. Pretty straightforward. You're given the velocity of one and you're asked to find the velocity of the other. We use the masses, their molar masses, from the periodic table.